So let's take a moment to review 4 very common ways AI is now used in language learning. One use is the use of AI tools for analysis. For example, analyzing students' reading and speaking skills. As a student reads a passage, AI can identify missing words or a mispronounced word or tally a student's speech rate. And once we have an analysis, then a second way AI can be used is for assessment, which, depending upon the metrics used by the developer or the teacher, the assessment might or might not be useful to the students. And I think that Professor Ribeiro is going to talk about how she uses pronunciation in the classroom and for students. So analysis tools might inform a third use of AI, which might be coaching or tutoring. If the AI detects the student is having difficulty, then a fourth way is to provide emotional support or encouragement. And so AI can do this based on the student's navigation throughout the materials, or even by trying to detect facial expressions to detect frustration. So there's so many different ways that AI can be used. AI can be used to generate from any web page or any corpus exercises targeting a specific grammar point that's targeted for a specific proficiency level. And so in addition to AI generating content and quizzes, it can be used in a very different way to enable two-way video interactions between the student and an on-screen character, for example, with the Sesame Street software. So a child's gestures and movements, the gestures and movements are detected by the AI software. And instead of typing, the child can respond through jumping or throwing or clapping or pointing. And it's very useful as a way to interact with materials if the child can't read or write yet. So Paul, I think I'd like to start sharing now, sharing my screen.
Please go ahead. Yep. Please go ahead.
Okay. There we go. So AI can also be used to recognize actual objects in the real world. Our smartphones can name the objects around us. And here we see that Google Lens is identifying a flower and offering more information about that flower. I'm sure many of you have used Google Lens to help you find information and about physical objects out in the world. And you can use open source object recognition code in your own projects, as I did. And as many of you already know, Google Lens can use real world objects as hyperlinks. Using your smartphone in a bookstore, for example, can quickly call up additional information about that book. For example, here we can see pointing the camera at a book brings up all kinds of additional information. I'm sure many of you have used these types of applications. I think Paul may be addressing that in his talk this morning. So here with Google Lookout, it's an app that is designed for blind people. It identifies and names objects for blind people, and it can read labels and signs as well. Of course, naming objects provides input that can be helpful to learners, but simply hearing the name for something is not sufficient for language learning, even if in this example, we can hear the translated words through speech synthesis.
Help. Help. ボトル、飲む、ボトル、ハサミ、ティッシュ、paredes, reloj, valla, árboles, hojas, モグラ色、スキ灰色、粘土、cassetti, cassetto, granito, بلوعة, حنفية, بلوعة, جرة.
Yes, it's impressive, but input alone, as we see in this still frame, input alone is not sufficient. You know, how do students turn input into intake? How might object recognition, typically used for simply labeling, how might it be used in a task in order to turn input into intake? So teachers and developers are needed to design and create ways to interact with input that help students learn a language. Let me show you an app I designed to illustrate how a teacher can use this object recognition code, Google Lens, for example, to create a task-based language learning game. So the name of my app is called, it's a prototyped app called Riddler. It's a guessing game where the smartphone camera will confirm what the opponents think is the correct answer to the riddle. The guessing game is designed for students to play together as competing teams or competing partners. It can be played synchronously or asynchronously. And here's how it works. One team works together to create a riddle to which an object is the correct response. And during this offline time, they work together to come up with a riddle for the opposing team. And then the students trying to solve the riddle talk together to decide what the answer to the riddle might be. And once they're ready to guess, they find the actual object and use their smartphone's camera to take a picture of it in order to find out if they found the correct object. So here we go. I've just taken some still frames from a video I made in my home, actually, to show you how this works. So welcome to Riddler. Start as a new player or continue. Find the object that answers your riddle. Take a photo and let Google Lens AI find out if you're right. So the riddle is, I have a spine, front and back, but bones and face are what I lack. So ideally, the team that's trying to solve the riddle talks things over, tries to figure out the answer, evaluating hypotheses and talking with each other. So if players know the object is in their environment, they may decide to walk around looking at objects for ideas. And if the student players decide the answer to this riddle is the dish here, they can take a picture of it to find out if they're right or wrong. And the AI software then analyzes the photo and tells them they're not correct. That doesn't look right to me. Of course, the answer for a book for the riddle was a book. I have a spine, front and back, but bones and face are what I like. So let's try another riddle. What has a tongue but cannot talk? Gets around a lot, but cannot walk. So the players talk it over and they look around and they see a shoe. Is it a shoe? They decide it is. And so they take a picture of it and then they're told, of course, you found the shoe. So let's look at another example that illustrates a task-based use of an object recognition. It combines geolocation with object recognition to create a navigation system for blind people.
Hey Carrie, let's go to Renaris.
Hi Nick, of course. Start by walking forward. Object approaching. Turn right. Turn left. Intersection approaching. Stop. No cars. Descending curb, step down.
So this sort of code could be repurposed to create a scavenger hunt for second language learners, don't you think? So Paul, let's stop sharing. I'm gonna stop the share here. All right, so my objective is to urge teachers to find ways to use AI in task-based activities rather than form-focused ones. The one takeaway from the illustration of my app, Riddler, is that collaboration and communication between students working together to solve each riddle will trigger negotiation of meaning as they discuss what the object might be and where they might find it. So the content and wording of the two riddles that we looked at is not our focus. A teacher or students could use this same template to create their own riddles to make a game appropriate for their own students' interests and proficiency level. So teachers can find better ways to use AI than simply labeling content. The presentation of input is not sufficient. Teachers and designers can do better. Think about it. We all get lots of input that we don't process because we don't need to. For example, take the temperature signs all over North America that are ubiquitous, and they flash centigrade and then Fahrenheit and centigrade and Fahrenheit. And we see those signs over and over thousands of times. We have massive amounts of input, but who in North America can tell you what centigrade association is to the Fahrenheit temperature? So the issue, AI and object recognition, friend or foe, brings us back to the question, how do students acquire language? What types of interactions are helpful for language learning? Well, negotiation of meaning, activities that require students to ask for clarification or to clarify, to check their comprehension, to make sure that they've truly understood. So language activities that motivate students to verbalize their reactions or elaborate are helpful for language learning. And language activities in which students must decide to agree or disagree with each other. Activities that require non-linguistic resources, thinking and reasoning to make decisions or solve a problem. So the navigation system for blind people, which could be repurposed as scavenger hunts, as well as the app I prototyped, Riddler, illustrate how teachers can design activities that result, I think, in integrating AI as a friend. They're examples of tasks rather than form-focused exercises. Object recognition allows us to break down barriers between learning materials and the social world, and it helps us reassess the relationship between the learner and the learner and the learner's environment. So this type of AI may be used in ways that really reposition the learner in the student's environment. And exploring the complex relationship between humans and objects is also important and becoming recognized in call research, as the current Journal of Language, Learning and Technology notes, that the relationship between humans and objects is becoming a very critical, important area of study in call. So in summary, coming down on the friend or foe side of AI, incorporating object recognition for language learning, let's compare the uses of object recognition. In the first uses we saw, the AI was simply used to label things. There was no task, no social interaction, no need to negotiate meaning, and no need to use non-linguistic resources. And in the case of the Riddler app, students do need to use non-linguistic resources. The important takeaway is that the AI using object recognition to simply create labels for objects will not have the same learning outcome as task-based social interaction incorporating object recognition. So, Paul, if we'd like to open this up for questions or comments.
Thank you. Yes, thank you for Professor Price. Thank you very much. If anyone has a question for Professor Price, could they go ahead and type it in the chat? And I will then unmute you and you'll be able to read your question. There's no questions right this minute, but hopefully some questions will come through. I have a clarification question. I think what you're saying is that inherently AI is neither a friend or a foe. It depends on how it's used. Would that be correct to say that?
Yes, I mean, that would be my perspective, yes.
Okay, thank you very much.
And that the metrics that are often used in AI may or may not be useful.
Yes, the metrics. And what kind of metrics are you talking about when you say metrics? Sorry.
Well, I think perhaps maybe I'm just imagining, but you have to remember it's 6 a.m. here in Boston. That I think Professor Ribeiro is going to address some of the metrics for pronunciation work, or is that right?
Let me check with Professor Ribeiro.
At any rate, metrics and assessment sometimes are global, sometimes they're specific, and the specificity can be off-putting and too much detail that students don't understand, or global may provide no direction as to helpfulness or what to do.
Is that your understanding, Professor Ribeiro? Do you echo that idea?
Yeah, I agree. And I see that the metrics side of using artificial intelligence is probably what schools, coordination directors have started to work on so that to understand, to have better insights on the performance of students and content and what to improve. But like Professor Price mentioned earlier in her talk, it's important to expand the usage. Okay, there is this tool, that's what can be done. And this is how the teacher who is actually interacting with a group of students, most cases, then let's consider teenagers and adult learners, what can be done of that in a communicative way, like she proposed, like a scavenger hunt or treasure hunt. And this would be very, very engaging to teenagers. As you were speaking, Professor Price, I was picturing the group of teenagers using this activity and follow-ups, because that's what teachers do, you know. So there are two important sides to consider.
Thank you very much. We do have a couple of questions coming through in the chat now, so I'm going to unmute Hugh Tran. Okay, Hugh, please go ahead and ask your question.
Oh yeah, it's simple. Just I'm interested in one example of how AI can be used for motivation, as you said.
So how can AI be used for motivation, Professor Price?
Well, I think the object recognition AI code, that is available open source for teachers and developers to use is quite motivating. The first time I showed it to colleagues and students, that, it's in itself, I think AI has can have a lot of flash and dash, I think that can be motivating. For example, people want to use the technology, but then again, how do you motivate is really the crux of all of our teaching, whether it uses AI or not, right? Understanding who we're addressing and understanding our population. I would say that the question is common to teaching with or without AI, don't you think? Or do you have a different perspective?
Are you asking Hugh? Are you asking Hugh?
Anyway.
Okay, I can unmute. Okay, let me ask you for a quick response to that. Go ahead, Hugh.
My name's it's pronounced Hui, by the way.
Hui. Sorry. I apologize for that.
It's okay.
Hui.
It's okay. No, I don't have anything. I was just looking for an example so that I could try to use it or envision it. That's all. But I do see what you're saying is the motivation. The motivation could be just that they successfully complete a task that is, the scavenger thing is one, or any other, task that is motivating that they complete besides,
Yes.
paper, pencil, and tests. So,
I
I
would
mean,
agree. And I think what's sad is when people look at, for example, object recognition apps or code, and they're motivated to use it, but don't use it in a way that actually will give the best outcome for learning.
Thank you.